guys, welcome back to my channel. Hope you people are fine. This is the part 16 for CSWIP 3.1 latest question technology paper. As I said you that this is the only channel you can get each question with explanation. So many of them watching the video, please subscribe, then you will get a notification for future videos and you will never miss this type of video. So let's start the first question. So the first question is, standard Oxy-Fuel gas cutting equipment can be applied to. So question is, standard Oxy-Fuel gas cutting equipment can be applied to. कहाँ apply हो सकता है standard Oxy-Fuel gas cutting equipment? So the first one is A, aluminium alloys, B, carbon steel, C is austenitic stainless steel, D is all of the above. So we should know that we should choose the correct option. So A is aluminium alloys. So the question is standard Oxy-Fuel gas cutting. So there is using oxygen. So what will happen? Aluminium alloys with oxygen, then they will forming the oxide in that material. It may be corrosive. Carbon steel, austenitic stainless steel also there will be problem in Oxy-Fuel gas cutting. Oxide formation in the steel, then it will happen problem in the corrosion. And D is all of the above. And B is carbon steel. Definitely carbon steel will be the answer. You see advantages. No need for power supply. Portable. Just I am giving more information. Second is versatile, preheat, brazing, surfacing, repair and straightening. This is Oxy-Fuel gas cutting advantages. Low equipment cost. Cost is very low. Can cut carbon and low alloy steel. So can cut carbon and low alloy steel. So here is option is aluminium alloys no. Austenitic stainless steel no, carbon steel yes, all of the above no. So what is the actual reason metal such as aluminium and stainless steel cannot cut with Oxy-Fuel due to the formation of oxide? So if there are oxide formation in the stainless steel and aluminium, that prevent what will happen oxidation from fully occurring. So if there is oxide, then that prevents oxidation from fully occurring. That is the problem in aluminium and stainless steel. So the correct answer will be the option B. Now we'll go the second question. Second question is the output characteristic of a typical MIG or MAG set is. So output characteristic typical MIG MAG set का option क्या दिया हुआ है? Constant voltage, constant current, dropping or pulsing. So what will be the output characteristic of MIG MAG set? Means MIG MAG welding. You see here the chart. This chart you should remember always. MMA is dropping constant current, TIG is dropping constant current, MIG or MAG that is called flat constant voltage. MAG FCAW that is flat constant voltage. SWIP means dropping constant current, flat constant voltage. If it is less than 500 amperes, if it is more than 500 amperes, that is the constant current. So electroslag is the flat constant voltage. So we will go the MIG MAG. So MIG MAG what will is there? Constant voltage. So correct answer will be the constant voltage. So that will be no. So answer is A, constant voltage. Now we'll go the third question. The penetrating power of an X-ray set is expressed in. So what is the penetrating power of an X-ray set? X-ray set का एक penetrating power है, वो कैसे express हो सकता है? Q is, B is kV, C is IQI values, D is the number after the isotope type. So this is different. This is totally the after the isotope type. This is for the gamma rays, but they are discussing the X-rays. Their question is asking the X-ray. So you see, this is very easy. Q is a unit of gamma ray, that is iridium 192. So this is the one unit for the gamma rays, but we are asking the X-rays. So this should not be the answer. Kb is the determined by the penetrating power of X-ray. Yes, X-ray penetrating power is Kb. So Kb is the right one. You see IQI values, what is it? This image quality indicator value used in radiographic film. So this is different. IQI values, it is used in the radiographic film. So this is not the correct one. So the correct one is the Kb. So answer is option B. Question number 4. A typical baking temperature for basic low hydrogen electrode is. So what is the typical temperature for baking for basic low hydrogen electrode? मीन्स हम लोग समटाइम्स बोलते हैं साइड में जो रॉड कितने डिग्री में हम ओवन में रखा और ओवन में कितना डिग्री में सेट किया. सो दिस इज कॉल्ड टिपिकल. सो एवरीबॉडी शुड नॉट नो दिस वन. One is A is 120 degree centigrade, B is 350 degree centigrade, C is 500 degree centigrade, D is 200 degree centigrade. I think you should know. Those people are working in as the welding engineer or welding inspector or QC inspector. He should know this information. You see here the basic electrode baking in oven 2 hours at 350 degree centigrade. Then it is go after baking. What will happen? The maintain in oven at 150 degree centigrade, or the sometimes it is 100 degree centigrade also. Client requirement, if it is you have the procedure maybe in mention there 100 degree centigrade, or the manufacturer recommendation if it is there, then maybe it will be 100 degree centigrade. So first you will do in oven 350 degree centigrade in 2 hours. Then it will go after baking maintain oven, means that is quiver. You can say quiver 150 degree centigrade. Then it will go used from quivers at to weld. After weavers you have to open the weaver and quiver, and you have to weld. And some of the parts you are not using, then if not used within 4 hours, return to oven and rebake, and again it will be rebake in this process. So this is the process. You understand the process. First 350 degree centigrade 2 hours baking, then after baking it will be maintained 150 degree centigrade, then it is used for weld, and some of the use, if it is not used within 4 hours, then it will return to again baking. So limited number of rebake is required. One time is okay. Again this electrode is coming here, and again second time. So it should not be do like this. Every time you should think that material you should finish in this first round. So the correct option, you understand, 350 degree centigrade is the correct one. So answer is option B. Question number 5. A burn through may occur because. Why burn through may occur? Burn through क्यों आता है welding में? The current is too high. Current बहुत ज़्यादा होने के लिए. The root gap is too small. Root gap बहुत कम है. The root face is too small. Root face बहुत कम है. Both A and C. So first is current is too high. If it is current is too high, definitely it will be burn through. It can be there. Root gap is too small. If the root gap is too small, means there will be not any penetration too much. Then burn through will not be there. So this will not be correct one. The burn through may occur means it's occurring, not stopping. The root face is too small. If root face is too small, definitely this is your joint. So you see here the root face is very small. Then for this one it will be happen like this way here. So burn through may be generated in this area. That's why this one. So A and C is correct. So I think that D is mentioning both A and C. I think this will be the correct one. Let's see. This is the causes. Insufficient trouble speed is there. Increase the trouble speed. Prevention. Excessive welding current, if it is there, then reduce the welding current. You have to. Lack of welder skill, if it is welder, then retrain the welder. Maybe need qualified welder, requalified. Excessive grinding of root face, if it is root face excessive grind, it will happen the root face is too small, then it could be generated the burn through. Excessive root gap is excessive, then insert correct fit up. So fit up we have to check first that root gap it is as per the acceptable tolerance limit, then we can proceed for the next run. So the answer will be the D. D is the correct answer, both A and C. Question number 6. Electrode classified as E43-2C and E6010, that is AWS A5.1, and another one BSE N 499 would usually be baked for 1 hour, delay the cooling rate. So E6010 be baked for 1 hour, delay the cooling rate. B not required baking. C is be dried for 1 hour at 100 degrees centigrade and stored at 70 degrees centigrade. And last one is a be dried for 1 hour at 100 degrees centigrade. So just I am giving my practical view also. You give your practical view. E6010 anywhere in your field required baking or not? Definitely, as per my experience, it's not required baking. So correct answer will be the option B. Option B is the correct one. You see here, 6010 is a cellulosic electrode. Cellulosic electrode actually have a small amount of moisture in the coating to help. So this moisture is there in cellulosic to help to bind the flux. This is very most important. So there also flux is there, moisture is there, but because it's to help bind the flux. This moisture is what gives these rods their deep penetrating characteristic. When put in an oven, this moisture is baked out of the flux and the arc becomes soft. So the correct answer will be the not required baking, 6010. Question number 7. According to BSE N 22553, what would an elongated jet through the dual reference line to the right of the fillet weld symbol indicate? So there is a, according to 22553 BSE N, there is one reference line that is looking like jade. What will be the weld symbol indicate? First is throw thickness, second is nominal penetration, C is leg length, and D is intermediate welds that are staggered. So we'll go to the explanation now. You see here, this is called the staggered, elongated jet through the dual reference line. So this is, you should know why this was jade, because the welding is like this way. If it is welding, this will be weld, then it will be gap here. Intermediate weld that are staggered, you see here. So this is 150, means this gap is 150 and this is 100. So you understand. So correct answer will be the intermediate welds that are staggered. So this is now, this is now, this is now. So correct answer will be the option. Answer D, means option D. Question number 8. What unit is used for tensile strength values? Joules, J per mm square, N per mm square, P per mm square. You should know this one. Joules, it is for energy. Tensile strength. So this is not for the energy. This is tensile strength. J per mm square. No. This is joule per mm square. Joule is for energy. Again I am telling energy. So energy per mm square. No, there is not anything like this way. Newton per mm square. So you know load by area. This is called the tensile strength. So load, if it is there, load it is can say Newton per area is mm square. So it is the correct one, Newton per mm square. Newton, you can say the load, how much load is there, Newton, we can you can do the unit Newton per millimeter square for the tensile strength. P per millimeter square, no. So this is not, only the answer is Newton per millimeter square. So answer C means option C is the correct one. Question number 9. In order to calculate heat input, it is necessary to know. So heat input formula, they are asking the heat input formula, how you have to do. Which things are required minimum requirement, then you can get the calculation. Current, voltage and thermal efficiency. Okay, you need current, you need voltage, you need thermal efficiency. Second, current, voltage, travel speed and thermal efficiency. C is current, voltage and wave width. And D is wire feed, voltage, burn of time. This is very interesting and important question. So many people know that is required current, voltage and travel speed. Okay, you know, but there is no option current, voltage and travel speed. So this is the explanation. If you go heat input as per ASME and AWS standard, you can see the voltage, and into amperage into 60 divided by travel speed in inch per mm or mm per minute. This is called the heat input as per ASME. So what is requirement? Voltage, amperage means current, and it is the travel speed. This is for the ASME or AWS standard. Now we'll go heat input as per, sorry, this one EN standard, European standard. So heat input as per European standard, if you go, then voltage into amperage into 60, travel speed in inch per mm or mm per minute into thermal efficiency. This is very important, into thermal efficiency. So they are adding in European standard voltage, current, travel speed, and the last one is thermal efficiency. So the correct answer, voltage, current, travel speed and thermal efficiency. The B is the right one. B is the right one. So answer is B, option B. Question number 10. Which welding position would normally give the highest heat input during MMA welding? So which position in C highest heat input, मीन्स कौन सा पोजीशन हाईएस्ट हीट इनपुट दे सकता है एमएम वेल्डिंग का टाइम में. PA is 1G. Position, all position would be the same. If never all position, they never can do the same heat input. Question number C. PC means 2G position. Okay, we can check one by one. And the D is option PF 3G. So the 1G, 2G and 3G. 3 option is here. Let's see here. 1G means this one, the flat. 2G means the horizontal. And 3G is the vertical. So you see flat here. Flat means this is your joint. Welder is doing welding the straight like this. So welder doing welding straight of this means it should be flat position. The flat position always the current will be more and the heat input always more. The heat input always more in 1G position is more. So correct answer is 1G. So answer is option A. Option A is the correct answer. Question number 11. What is the following is the typical heat input value for MMA welder? So in MMA welding, what will be the typical heat input? So there will be typical heat input, there will be range. So let's see, 58 kilojoule per mm is too much. 1.5 joule per mm. So joule per mm, no, it will not be heat input unit. 58 kilojoule per mm, it's too much, never. Question number option C, 5.8 kilojoule per mm. This is also more. D is 1.5 kilojoule per mm. So we can say the 1.5 kilojoule per mm. It is the experience. When you will do in any welding job as a welding inspector and you are doing daily welding inspection in your site, then definitely you can understand the D will be the correct one. Also, I am giving typical heat input values between 1.3 to 2.9 kilojoule per mm. So this you have to remember, 1.3 to 2.9 kilojoule per mm. This is the typical heat input value for MMA welding. I think hope you understand all the question. If you have still any query, then you can just ask me in the comment, then I can explain to you. Thanks a lot. Those people still not subscribe my channel, please subscribe, then you can get a first notification for all my upcoming videos. Thanks a lot. Take care. Please like, share and subscribe my channel to get the regular videos. Thanks a lot. Take care and see you soon by next video.